Today we're just going to do some test review stuff. So as a reminder, this was the test description that we had written out earlier. So you should be able to find like a general antiderivative and specific antiderivatives using boundary condition. Reminder, what's the difference between general and specific? Very good. So the general just has a plus c at the end. The specific, you'll use the boundary condition to solve for the c. Yep. You should be able to evaluate a definite integral using any method, either calculator or by hand. Should be able to calculate the area under the curve, if you're given a picture end function. Calculate the area between two curves. Use the trapezoid rule to approximate an integral, given a table of points or a scatter plot. And then do integration story problems. So that's the description that we wrote out. I'm just going to grab some problems from the review from the textbook, and we'll do some of these. I would suggest to have something to write with and or your calculator, so you can participate and follow along and all that jazz. Oh my gosh.
Oh my goodness. What happened? Are the question number one in the homework A through L?
Well, this is the review.
Can I change my missing to like 1 through 15 like email? Oh,
this isn't even the homework.
50 years of parts. It's not on my.
This is the review that was unassigned that we're looking at right now. Okay. So if we look at number one here, it's just asking us to find the general antiderivative, right? Take a look at these. Which one of these looks like the scariest one?
Probably
J is pretty scary.
J looks pretty freaky. Oh no, I.
J, the I's not
Wait.
Do you know what to do for H? You definitely don't want to take a square root of it.
Distribute squared.
Ooh, squares don't distribute. Yeah, Olivia's got the right idea. Let's FOIL it out.
X plus 1.
So we'll need to do a little pre-integration algebra to get that into a form where we can apply our rule for integration that we have. Everybody feel okay with what I did here to start? Okay. What's the antiderivative of x to the fourth? Yep. And then the antiderivative of 2x squared?
X, 2x cubed, or 2x over the third.
Okay. And then the antiderivative of 1 is?
0.
Not 0.
X.
Yes, just x. Is this finished?
No.
No. What's wrong with it? We need a plus c. Everybody feel okay on that one? So the trick there that you needed to was that how to deal with the squared. Because the way it's currently written, you do not have the derivative rules to differentiate it the way it's currently written. Now there are rules to do that, but it's beyond the scope of this class and we're not going to cover it. But that should be something we can still handle with a little bit of algebra. Maybe let's look at M. It's probably another good one. Can we integrate that as it's currently written if your name's not Maria? Okay, we cannot. What do we need to do to it? Yeah. So we'll want to probably write it as two separate fractions with a common denominator. And then we can reduce and then just rewrite with negative exponents, right? Feels so far so good? Okay. And so someone other than Sam, can you tell me the antiderivative of 300x to the negative 3? Yeah, I called for someone other than Sam who was doing all the parts for the other one, which is great. Not quite. So, yeah, let's just leave all the numbers. Let's write it that way. So we add 1 to the exponent and then divide by that new exponent, right? And you can simplify that for sure. As Olivia said, negative 150 h to the negative 2 is correct. But I was going to write it this way first so it's easy for everybody to see what we did there. Not incorrect, though. And then the next piece is negative 2h to the negative 2. How does that antiderivative?
So just 2 over h.
2 over h. Yeah, yep, that'll do. I'm going to write it this way first, but you're correct. 2 over h will be what it simplifies to. Absolutely. So I took 1, added it to the exponent, and divided it by that exponent, right? So that's all I'm doing there. Does that feel okay, Eve? What's this missing, though? Plus c. Okay. How do you guys feel about general antiderivative? Okay? This should be like fairly straightforward. We've practiced this a bunch. It's been on the quiz. It's basically the reverse of what the last 2 chapters have been. This should be amongst the easier problems. Let's look at some of these definite integral examples. So if you take a look at this, some of these are doable by hand, and some of them are only doable for us via calculator. Can somebody tell me which ones are calculator only? Joe? We're looking at number 2.
Oh, sorry.
Not the graph. That's okay. Okay, which ones are the calculator only ones? B for sure, because it's an exponential function, right? The only stuff we know how to do is power function. What else? What? E is correct. Remember, our power function antiderivative rule doesn't work if the exponent is negative 1. And then the last one is, there's one more that we can't do by hand.
C.
It's D. What's wrong with D? The absolute value. Yeah. So those 3 are ones that you would need to use your calculator to do. Is that okay with how we saw that? As an aside, does anybody remember? I told you guys what the antiderivative of 1 over x was. Does anybody remember? It's beyond the scope of the class. You don't need to have remembered, but we mentioned it. Yeah, except for maybe Maria. It is the natural log, yes. That is your antiderivative of 1 over x. So let's do one of these on the calculator, just to remind you guys how to do that. So I'll do D. So to get the integral symbol, where do we go?
Math. Like 9.
Yeah, math and then command 9 on my calculator. It's called fn int. -3 to 3. And now I need the absolute value symbol there. So to get that, I go back to the math menu, number, ABS, and then I'll just type in the function exactly like it looks like on my sheet of paper, and then dx, and we press enter. Answer spits out. Feel okay there? Okay. What if we wanted you to do this by hand? Let's do one of these guys by hand just to remind us how that works also. Let's do C, just because it's at the end and it's convenient for me to find a spot to write it. Sound okay to you guys? Okay. So first step would be to find the antiderivative. So the antiderivative of x cubed is? Great. And then of negative 9x? Good. And then we need to evaluate that from -3 to 3. So we'll just plug in the 3 to start. Now I'm going to make sure when I subtract the -3 plugged in, I want to make sure I put a parenthesis there. Your most common mistakes while doing something like this is just goofing your negative signs because you forget to distribute that subtraction symbol through the entire other piece. So we have 81 over 4 minus 27 over 2 minus 81 over 4. Oops. As a -3. Still minus 81 over 4. And then we have minus, and so that's a plus. 27 over 2. So these guys cancel out and we're left with just 27 over 2 plus 27 over 2, which is 27. If I have 27 halves and another 27 halves, I have 27 wholes, right? Checks out. Did I goof something there, Mr. Boyle?
Did he do something?
Oh, it sure did, right? That's 9 times 9, that's 81, right? Not 27. There we go. Thank you. Still? What else did I
What do
goof?
you do?
He messed up.
I done messed up here somewhere.
It's okay, everyone makes
Is
mistakes.
that just 0?
Oh, there we go. Yeah. Dur. Woo! Who's got the after lunch sleepies?
Me.
It's like Jake.
Wait, also,
Looks like Jake does.
I feel better about myself.
Yeah, no problem. It happens every day. Anyway, got the idea though? Like no big deal on this, right? Even if you need to do it by hand, it just do the antiderivative, plug in and subtract. Try not to make arithmetic mistakes. The good news is, what can you do even if you have to do it by hand? Check it with the calculator, because you'll always have access to the calculator. All right, let's do it then. So this was that guy, right? Zero.
Joe, get out.
I don't know. 0 appears to be correct, though. All right. So just to be clear, if we go back and look at our test description, we've done examples of this type. We've done examples of that type, right? All right. Let's continue. So it says here to use the graph of f of x to find the given integrals. The curved segment is a circular arc. So the first question asks us to go from the integral from -5 to -2 of f of x dx. So remember that an integral is equivalent to the area under a curve. So we're just looking for this area. What shape is that? Rectangle? What's the area formula for a rectangle? That's a cubic or something. Yeah, length times width. That's side times side. So one side is length 6, the other is length 3, so that's got to be 18. Good so far? Oops. The next one, yeah, that's it. The next one is from -2 to 0. What shape is that guy? That is a trapezoid. Very good. The area formula for a trapezoid is 1/2 base 1 plus base 2 times height. So base 1, base 2, and then height. Yes, sir. I think probably the area of a rectangle I'd expect you to have, but trapezoid I think I would give to you. Area of a square you probably have to remember.
I think you should probably that's circumference.
All right. So 1/2 times 6 plus 3 times 2, that's just 9, right?
The other side.
The next one is from 0 to 3. So 0 to 3. Yeah, so it looks like a quarter circle is what Jack said. This little section here. The radius is 3. I know the area of a circle is pi r squared, and since it's a quarter, you know, it's 1/4 of 3 squared times pi, or 9 pi over 4. All right. Next one is the integral from 3 to 5. What is that shape? Yeah. It's a right triangle, which is even better. What's the area formula for a triangle? 1/2 base times height. Base and height are both 2 times 1/2. Just going to be 2. And our last one says the integral from -5 to +5. So it's here all the way to there. How are we going to find that? Add up the other answers. That's exactly right. Now, come on now. I hate you. OneNote thinks I'm trying to erase stuff just because I'm not trying to erase. I'm trying to keep that there.
Maybe it's not your friend today.
We're fighting for
You're
sure.
beefing.
Yeah, me and OneNote.
Beefing with one
Yes, Joe.
Is it 18? Because it's 1/2 times 6 times 3 times 4.
It's 1/2 6 plus 3
Oh, it's plus.
times 2. That's okay. All right. What do you guys feel? Okay on something like this? Pretty easy, right? Like if you just understand conceptually what you're doing, the actual computation is pretty easy. You're just kind of piecing the thing together by adding up areas of simple geometric figures. That's as complicated as it needs be. Let's go and do another example. This time I'm going to pick some scary story problems. Ooh. This is how all these IB questions work. You can't be surprised that there's so many parts. Yeah. So this one says fuel tank A is filling from fuel tank B at a rate of dV/dt equals 3 minus 0.1 t, where t is in seconds and dV/dt is in liters per second. Write down an integral expression for the volume of for the fuel in the fuel tank A after t seconds. So we want a function for volume in terms of t, right? Everybody read that much from there? Joseph? I would say they're probably asking you to write it as an indefinite integral. But we remember that to get volume, we just need to integrate dV/dt then, the derivative of volume. Or you could write it as that guy. This is how I assume that the IB would be looking for it. In reality, the way that I would have written this would be like this. So it's actually like a function in terms of x, or in terms of t, instead of just like before, but whatever. This is what I'm assuming the IB would be looking for. Maria will be more familiar with the second one. Mr. Boyle, Maria is also in the AP Calculus course, is why I keep referencing that she should know these things that everyone else doesn't. Yeah. So you all missed out.
I would be able to last. I can't even do it one.
I know. I know. It's okay.
No, it's not. No, take me back to geometry. Trig and pre-calc was like, I failed. I hated trig. I was doing Nico Plums.
I got a 73 pre-calc while I actually tried.
All right.
Dr.
And that one like intern.
When I sat there and Nico Plums sat there,
Yes.
we would trade tests. Since all the grades are final, we would trade tests, so I would do his test for
All right. Part B says find the volume of fuel transferred to fuel tank A from fuel tank B in the first 10 seconds of filling.
Wait, we have story problems? So we plugged in the 10. Do you have to find the derivative?
So you don't need to find the derivative because you have that. So here's what I would tell you. I want to be really clear because these are all good questions that you're asking right now. I would say there's not enough information to actually answer this question because the textbook has denied you a very important piece of information that I think they want you to just assume, but I think they need to state. Yes, they do not tell you how much fuel is in tank A. I think the textbook would have you assume it's empty. I would say this problem is impossible the way it's currently written because that is a necessary piece of information.
Maybe it's too early for math. Actually, be good.
I've discussed before what I think of the editors that worked on this textbook.
And they might even have accurate answers in the back.
So you could do v of 10, taking your antiderivative from part A. I guess let's do that.
Mr. Fuller,
Yes.
if I get my homework, one of the homework done, can I show you it after you're done?
Sure.
Instead of turning it in and emailing you?
That would be fine.
Okay, thank you. Thank you.
So you could do it that way. Shh. Or you could think about it this way. You'll get the same answer either way. What's the advantage of doing it the second way? The calculator will do it for you. So you don't have to actually rely on being able to do the antiderivative correctly. Although, come on guys, that's a pretty easy antiderivative to do. But if you're doing this, then the C doesn't really matter, because it'll just get canceled out if you're doing it as a definite integral. But if the tank was already filled, then I don't know that it would continue pumping, but whatever. Part C says fuel tank A has a capacity of 40 liters. Find the time when fuel tank A will be full. So what are we looking to do there? So you're looking for when V of t is equal to 40. That is correct. So you could do this one of two ways, right? You can take the antiderivative that we wrote and solve it equal to 40. Or you can do the integral from like, go ahead, Nora. You're welcome. Or you can graphically have the calculator graph this and find the intersection, right? So you could solve one like a quadratic, or you can graph it and find the intersection. It doesn't matter which route you want to go. Let's show you the graphing way here. Again, what's the advantage of doing it the highlighted yellow way?
Calculator.
Yeah, the calculator is going to do it for you as long as you know how to ask it nicely. And even though our calculators can't do an indefinite integral, it can graph it. So that's what I'm going to graph. But let's think about our window here for a moment. Our x value is a time, right? What value of x do we know it has to be more than? Okay, what other value of x do we know it has to be more than? That's good. Our answer from the previous question, right? Because when I type this in, I'm going to get, I guess I could have done that. Probably should have, huh? Let's do that real quick. Make sure it's not over 40. That's probably a good thing to have checked here. So that's 25. So if you're going to make an estimate for the upper bound, it's got to be more than 10, right? So at 10 seconds, we're at 25 liters. What do you think? Let's do like 30 seconds. That should be more than enough to get us to 40, don't you think? Just as a guess. Now the y's are going to be the volumes. So probably 0, and then the y max has to be bigger than what number still? 40, because I need to be able to see the intersection on my calculator. Yep. So
Oh, I see.
I want to be able to see the intersection. I want to see where it crosses. So I'm going to pick something a little bigger than 40. Now, here's the only downside of doing it graphically. What's the downside? It's slow.
Wow.
But it'll do it. And I don't have to worry about like, ooh, did I mess up that antiderivative? Because if I did, like, everything after it's wrong. Although it's not a hard antiderivative to do. Like, come on, folks. Like, we can do that. But there's my graph of the antiderivative and the graph of the line. We just need to find the intersection then. And again, since there's only two curves, I'm just going to do enter, enter, enter real quick. And it tells me t equals 20.
What was the top line again?
40. That was y equals 40, the other side of the equation. How are we feeling still? Doing okay? Okay. Part D says, after fuel tank A is full, fuel tank B is then used to fill fuel tank C. When dV dt is equal to 0, there's no more fuel in tank B. Find the time when this occurs. What are we being asked to do? We're just solving this, right? Well, that's not so bad. Because they told me dV dt in the problem. Oh, Mr. Kulik, this is so simple. I guess I should write some of these things in. Everybody feel okay there? All right. So part D2 then says, hence find the number of liters in fuel tank B before filling fuel tank A. So there's two different ways to do this. So you could do 25 plus the integral from 20 to 30 of dV dt. Why the 25? Oops. That should be 10 to 30. Excuse me. Right? Because we knew that in 10 seconds I filled up 25. After 30 seconds, we're empty then, right? Could have done it that way. Or, similarly, you could do 40 plus the integral from 10 to 20 of dV dt. Again, because you know 40 liters fills up tank A, and then there's okay, 20 to 30. And then there's 10 more seconds from time 20 to 30. Or you could just do that. All of these are fine. They're all going to do the same thing. And this should imply something to you about a rule for integration. That if you have assuming that f is continuous. So basically it's saying that if I have a curve and say this is like A, B, and C, that this area plus this area is going to be the same as that area. Which, no doy, Mr. Kulik. Of course that's got to be true, right? Should make perfect sense that that would have to be the case. How's that? We feel okay there? So just checking back in on what we've done. So we've done area under curve using a picture. We've done some story problems. Let's do some more stuff. All right. That's a good one. All right, the Red Chair Company. I wonder what they sell.
Blue chairs.
Blue chairs, yeah, probably. Yes, they're obviously the Chinese company, the Red Chair Company. We're making jokes about communism because it's the Red Chair. Yeah. Yeah. All right. The Red Chair Company sells N red chairs per month. The marginal profit in GBP can be modeled by the function dpdn equals 3n minus n. I'm sorry, 300 minus 3n. GBP, I'm assuming it's like Great British Pounds. Would be my, I don't know. I think I'm just doing it from context clues because it's clearly some kind of money.
Yeah, pound sterling.
Yeah. It says find the number of chairs that should be sold in order to maximize profit. Yeah, it seems that way. Okay. How do we find a maximum using calculus? Well, we have the derivative, right? So that's correct. We'd want to start by setting the derivative to 0. Excellent. That is correct. So take dpdn, set it equal to 0. And again, if you want to do a first derivative test, that's not my recommendation here. If I fill that in to here, I would get 300 minus 270, and then 300 minus 330. So we're moving from negative to positive. So that is a local maximum. Or what I would have done is the second derivative test, because what's the derivative of 300 minus 3n? It's negative 3, right? Which is less than 0 for all t. So therefore, I should say, it's supposed to be an n down there. So then n equals 100 is a local max. That's easier to me because there was less computation involved, but whatever your preference is, it doesn't matter. They're both valid. One is not really much more time consuming than the other. Now part B says the profit from the sale of 40 chairs is £5,000. What did they just give us here? It's like our boundary condition, right? That's what we'd called those. So that's like a point, like 40 comma 5,000, where that's like an n and a p of n. Does everybody feel okay there? So what's that going to allow me to do?
Solve for C.
Okay, so yeah, so that's going to allow me to do the, like, find the specific antiderivative given a boundary condition. So just kind of trying to connect back to there. So P of n is going to be the antiderivative of 300 minus 3n dn. Everybody feels okay there? And we'll just plug in now to solve for C. 40 really expensive chairs. And then through the magic of having already done the problem earlier today, I know that C is negative 4,600. Because I did this already once, you know. It's amazing that I can still make mistakes on previous problems, but you know, we all have our moments. I usually do at least once a day. So there's my P of n. I'm really human then. So far, so good? No. Can't argue then. All right, let's see. Part 2. Find the profit from selling 80 chairs. How am I going to do that? Just plugging 80 into the answer we just generated, right? We don't know it's linear. And in fact, we know the curve's not linear because look at that. It's quadratic. So, good question. Very tempting to want to just say, oh, times 2. Nope. All right. Yeah. Well, it should be. All right. And I'll leave that to you guys plugging that in, right? No big deal there. Part 3 wants to know the least number of chairs that must be sold in order to make a profit. So what are we looking for there? Profit is making a profit means the profit should be positive, right? So I'm just going to go and want to do that. So I'll solve P of n equal to 0. Very good with that plan? Sure. So we'll just use, since we had to do the answer here, let's use our answer. It's probably why they had us find it. Did I get too many? No, I think I got the right number of n's there. No. Yeah, it should definitely be 300. Mr. Kulik, again, making typos. I was like, 3,000? Where's that extra 1,000 coming from? At least I caught it before I got too far. Thankfully, by not plugging in the answer before, I saved myself from another mistake. And now, what I'm looking for is where this is equal to 0, right? So, I know that my y values, I'm just going to make from like negative 1,000 to positive 1,000, because really all I care about is where it's crossing. Now, this x is our number of chairs, right? Where do I know that profitability has to happen between? Well, 0 and 40, right? Because we know 40 is the maximum. So it has to start below that. If you make 0 chairs, you can't possibly be profitable, because why would you ever bother making chairs if I can make money for doing nothing? Good deal. So we'll go from 0 to 40. Somewhere in there, we should cross the x-axis. There we go. That was so fast because I didn't have to do an integral. So second trace, 0 command. Again, you could solve this using the quadratic formula or something if you wanted to, but like that looks like a pretty nasty quadratic formula there. So I get about 16.7. How would I want to round that? Reminder what the question is. Want the least number of chairs in order to make a profit. Should it be round down to 16 or up to 17? Up to 17, right? Because if we looked at the graph, if I'm less than 16.7, I'm not profitable. Everybody's good? Caught it? Okay. So it's not because it was 16.7 that we rounded up. If it was 16.1, we still would have rounded up. Everybody's cool? All right. And then part IV, find the maximum profit. How do we do that? We already did it. Right? All we have to do is plug that into just plug it into P and we're done, right? Everybody happy? Okay. You're joyful. All right. Let's do a little piece of another problem and we'll talk about area between two curves, and that'll should do us. All right. We're just going to worry about part A here. So it says the velocity of a car braking to stop on a wet road is recorded in table 11.4. It says use the trapezoidal rule to find the total distance traveled by the car. Using a GDC, we can find a line of best fit for this data is dsdt equals negative 4.76 t plus 28.7. So I know that distance is the integral of velocity, right? And this is our velocity, right? And we are going from 0 to 6 seconds. So I can approximate that using a trapezoidal rule. So I'm going to make a trapezoid using the first 2 points, and then a trapezoid using the second 2 points, and then a trapezoid using the third 2 points, and then another trapezoid using the last 2 points. Everybody feel okay there? So these are going to be my heights, and the change in times are going to be my heights. I think I said the wrong word before. The speeds are going to be my bases. Excuse me. So T1 is just going to be 1/2 28.4 plus 24 times 1, because the distance from 0 to 1 is 1. Trapezoid 2 is going to be 24 plus 19.5 times 1. Again, the distance from 1 to 2 is 1. Trapezoid 3 is going to be 1/2 19.5 plus 9.6 times 2, because the distance between times is now from 2 to 4. And my last trapezoid, 1/2 9.6 plus 0 times 2 again. And then we just add all that up, and that'll do it. Feel okay there? So again, that's then the using the trapezoid rule to make an approximation. Feel okay there? You're just making a bunch of trapezoids and adding them up, right, Isaac? Yeah, the only other thing you might get is a scatter plot, where it's doing the same idea. You know, like if I had these points plotted, you're building the trapezoids just like it's essentially the same thing. It's just like a different presentation. Okay, the last thing that we haven't talked about is just this area between two curves. I'm just going to talk about this kind of in an abstract fashion, I think, as a reminder. So let's say this is curve 1. We'll call that f of x. And let's say we have curve 2. I'll call that g of x. And we're looking to find the area between the two. Everybody feel okay there? So the idea here is I'm going to need to find these points of intersection. For the sake of argument, I'm going to call that one A and that one B. How would you do that in practice? Graph it on your calculator, find the intersection, right? You could set the two functions equal to each other and solve, but you may end up with a problem that's intractable. Like if you have an exponential and a polynomial, like there's not an algebraic way to solve that. You literally have to graph it and find the intersections. Yeah. Well, what I want then is basically the way I think about this is that area in green should be the area under the red curve minus the area under the blue curve, right? So that's going to be the integral from a to b of the curve on top, f of x, minus the curve on bottom, g of x, dx. Does that make sense? And again, like at that point, it's calculator time, right? I mean, you could do it by hand if you wanted to, but I would just put it into my calculator. And again, if you wanted to, depending on how you wanted to format things, that this also would be equivalent to that guy, right? Whether you want to write it as a single integral or the difference of two integrals, same thing.
So what happens when we have the y and the x-axis? Box off one part. You only take the part that would be.
So if you had this bound by like the x and y axis, you would just, instead of going from A to B, you'd have like C to B, you know, and it'll be, well, then you'd have to actually junk out this chunk here. You wouldn't get anything that complicated though. Like you'd have to do, to get that to work, you'd have to then, really you're just doing, you know, like the area under A minus just this little tiny sliver right there for B. But I wouldn't worry too much about that. More common, Joseph, would be like if you had got would be something like that. Or again, this is like your A. Or just now your start is at 0 and you just need one intersection. What Maria knows from AP Calculus is when they get real tricky is they give you something like this. Where you have like two separate regions and we switch which one comes on top and which one comes on bottom. And the workaround there is you just do the absolute value. And then it doesn't matter which one's on top and which one's on bottom. That's the trick, the workaround. And you're free to use that if you're like, I don't remember which one has to go on top and which one needs to go on, or which one should be subtracted from which one. Just do the absolute value then. It doesn't matter which way you write it. You get the right answer. Nice! What do you guys think? At this point, this should be fairly easy setup conceptually, right?
So in a higher and more advanced math, the next step from this,
Oh, going from areas?
Yeah.
You go to calculating like volumes of rotation and stuff. So like, say we have like, like this curve and this curve. You have like that area, and then say you rotate that area about like this axis, and you want to find the volume of the figure made in 3 dimensions. So that's kind of like the next step. And this would be like super relevant for anybody that's in any kind of manufacturing where you need to find out how much stuff, raw material you need to make something. Like, how do I figure out how much volume this is when I can, sketch out like the flat piece? That's the idea. Would be what comes next. And now, Maria, volumes of rotation, hard or easy?
Hard.
Pretty hard. Pretty hard. It's a pretty hard Calc 1 topic.
That makes me think of a car wheel.
Yeah.
Like you'd have a more complex shape for a car wheel, but you have a local section, and then you do a 360 of it, and then you're taking on other material as well. So like from a manufacturing standpoint, yeah. And Mr. Boyle spent, if you don't know, years in working in the automotive industry as an engineer, doing exactly these kind of consulting problems. Seals would be another one. Yeah. Extruding lenses. Yeah.
Math teachers.
Algebra 2 and fundamentals of algebra, so the 3 algebra. They still have the scars. Yeah, he's
Anyways, that's basically the test in a nutshell. I don't have anything more to show you guys today. If you guys have specific questions or individual questions, I'd be happy to deal with them, but I think I'm done for today. You guys feel pretty good? Yes, done for today.